now that we know how to complete an entire paired t-test by hand, let's practice again, but this time a computer program has been used to do a lot of the calculation heavy lifting for us. So suppose researchers want to know whether the use of cell phones impairs reaction times in a driving skills test. Reaction times in milliseconds are measured when subjects perform the driving test without using cell phones, sample 1, and then again with the same subjects using cell phones, sample 2. 4 observations were taken from these two conditions. Subjects had a warm-up time interval to become familiar with the task, so reaction times would not tend to change from one condition to the other merely because of increased familiarity. Okay, so they have you driving and you're performing a skill, and they want to know if using the cell phone impairs your reaction time.
Yep. But it's not just a tablet, it's really a laptop. It's a Surface Pro 3 with a touchscreen.
I have two different computer outputs here.
Well, it can't be as fast as my Mac. Sure it can.
And as per usual, you won't actually get both on an exam or a project. You'll have one or the other, and you're going to have to be able to apply what you're learning to whichever one is given.
So you're saying it does more than my Mac? Well, technically.
So how many people were sampled altogether? Well, in Minitab, it's really easy to see. I've kind of put in this little blue box right here. It's 32. Now, it's a little bit harder to see in StatCrunch. If you were only given StatCrunch, you'd have to use the fact that the degrees of freedom is 31, which I put in that little blue box right there, and you'd have to add 1 to it in your head and make 32. Now, the degrees of freedom, easy to spot in StatCrunch. It's 31, but if you were in Minitab, you have to use the fact that n is 32, and you'd have to subtract 1 from that to get the 31. So whichever program you're given, one of these two calculations will have to get made. So if you're given Minitab, you'd have to figure out your degrees of freedom. If you're given StatCrunch, you'd have to figure out your n value. Right, now what was the average time when not using the cell phone? Well, that's only available in StatCrunch. It's right here. It's 534.6.
My goal is
if I gave you StatCrunch, I couldn't possibly ask you that question because StatCrunch doesn't actually have that information up here. It's nowhere to be found in that output. So you have to hope if I give you that, well, not only have to hope, but if I give you that question, then I must have given you Minitab because Minitab gives you more information. Similarly, Minitab is the only one that gives you the not using the cell phone time. See 66.4 standard deviation, 534.6 for the mean. Those are both in milliseconds, by the way. MS is the symbol for millisecond. All right, now what they both do give you, however, is the difference, the average difference, and that's in the little red box. So the difference for StatCrunch is really easy to see because it says difference right above it. The difference for Minitab is a little bit harder to read, but it's right here, the mean for the difference right there. And then the standard, well, let's just talk about that. That's negative 50.63 milliseconds. All right, now SD is a little bit trickier to find. Now, I grant you, Minitab actually gives it to you. It tells you it's right here. It's 52.49. See it? However, chances are I would block that off or not give it to you. So how could you find it? Well, if you use the standard error is 9.28. So that's where I get that value from. And then I remember we have a formula for standard error that uses the formula we learned in Chapter 8, namely that standard error of a mean is equal to the standard deviation divided by the square root of n. All right, now normally it's the population standard deviation, but we don't actually know that value here. All right, so the standard deviation I'm not sure of, but I know that the square root of 32 would be the square root of n, and then I know that it's equal to 9.28 because that's given here as the standard error. See the little yellow box? So you could multiply 9.28 by the square root of 32 to get standard deviation. So let me grab my calculator. 9.28 times the square root of 32, and I get 52.4956. So that's where I came up with 52.496 as my standard deviation. All right. That's a whole bunch of just knowing how to read this output, right, and look for particular things. Now, the problem states, quote, suppose researchers want to know whether the use of cell phones impairs reaction times in a driving skills test. So let's think about this for just a second, and then figure out which hypotheses this means. Now you can look into the output and you can tell this is a left-tailed test right here. Actually, let me highlight that for you in both pictures. One second. There, I'm running out of colors. I kind of had to make it this dark teal color here. All right, so you can see really obviously in StatCrunch what it is. It's a less than test, but it's much harder to read in the Minitab output. So Minitab first has this bit up here about it's not using cell minus using cell. That lets you know which group is group 1. The not using group is the front group, and the back group is the using cell, so that would be group 2. But where is the alternative hypothesis? And it's actually down here at the very bottom. See where it says versus equals 0 versus less than 0. It's a t-test of the mean difference meaning mu d, right? And then it's versus 0 meaning, or excuse me, versus less than 0. So that means you're doing a left-tailed test. So it's a little bit hard to read, but that's what it actually is. So that's how we find this value right here. That's the left-tailed test. But now let's explain why that works. So remember that not using the cell is group 1 and using the cell is group 2. And you can see that from either computer output. It's right here. It says not using cell minus using cell. And then up here it says mu1 minus mu2. See where it says not using cell and using cell? They're telling you which group is first. They're telling you that the not using cell group is first. Oh, and also right here, look. Not using cell minus using cell, it's right there as well. So there's a couple ways to find it there. All right, so since it says that, that means that the computer output is telling you that it's not using cell as your first group, using cell as your second group. So you're doing group 1 minus group 2. And the word impaired. Impaired is right here, impaired. That means that you're having a slower time, right? It means it takes you longer, right? So that means that your reaction time, impaired reaction, means that not using cell should have a smaller reaction time than using the cell. Okay, so that means when you subtract, you should get a negative value, right? In other words, the group 1 number, not using the cell, you should be able to do this reaction on this driving test faster than when you're using the cell. If this number is smaller, takes you less time, then this number, which is bigger, takes you more time. Smaller number minus bigger number means negative, right? It should be negative, less than 0. And that's where that comes from. Just on a side note here, remember, this is not the first time we've run into this. You've got to be very, very, very careful with how you set up your hypotheses, because hypotheses can go left-tailed or right-tailed depending on how you set them up. It isn't really about the word impaired. It's about the word impaired and which group was first. So because the not using cell group is first, and that should be the smaller group, that should be the one with lower times, that's what makes this less than 0. If it was the using cell group, then it should actually be more than 0. So it all depends on which group you set up to be group 1. Because group 1 is your not using cell group, your leader group. That's why this is less than 0. All right, now the computer outputs for both of them really talk about mu1 minus mu2 equals 0. Mu1 minus mu2 is less than 0. It's a little bit harder to see in Minitab, but they say it right here with the not using cell minus using cell. That's group 1 minus group 2. All right, now why is that okay? Well, it's not great. Technically, because it's paired data, I don't particularly like that notation. However, I can explain why it works. Group 1 is the not using cell group. Group 2 is the using cell group. We know that we want to know if not using is indeed less than using. Does it take you less time to react when you're not using a cell phone than when you are using a cell phone? Because of course in driving, reaction times are very important. It can be the difference between life and death. So we have the mean for not using and the mean for using, right? So hypothetically speaking, if until we've tested it, we think they're equal. So you subtract the mean from using from both sides, and that'll give you mean for not using minus mean for using equals 0. So there's your null hypothesis. The mu d is equal to 0. Then the alternative would be that you think that not using is less than using. So when you subtract the mean for using from both sides, that'll get you less than 0, just like we said above. And that's why mu d is less than 0. So they're the same hypotheses, they're just kind of written differently. All right, so that's what I just wrote here. They're basically the same thing, it's just that they're written differently. We will always, when we're working with paired t-tests, use mu-d, however. We will not use this notation. Computers use it, but it's not a great notation for a paired t-test, at least as far as our textbook is concerned. All right, now if we had found the differences by going the opposite way, if we had gone sample 2 minus sample 1, then that would have been the opposite, right? The alternative would have flipped on its head. So let me type that up. All right, there we have it. So if we put the using group in front, that's what they're telling us to do. They're saying, hey, do sample 2 minus sample 1, do using minus not using cell. So if that's the case and you do that, you put it in front, then when you subtract, right, it'll be using minus not using, just like they said, which will be equal to 0, and that means the mu-d is equal to 0 as your null. So that's no different. But what is different is this part, your alternative. See, we think that the not using should be the smaller of the two groups. We think that when you're not using your cell phone, you will have less time it takes to react, right? So we think that the using time reaction will be greater than the not using time reaction. So when you subtract using minus not using, you think it will be greater than 0, which means mu-d is greater than 0. In other words, it reversed the sign. Group 1 minus group 2, like we did up here, made it less than 0. Group 2 minus group 1 makes it more than 0. And this is why I tell you, you've got to be very, very careful with how you set up your hypotheses. It's all based on how your sample is. If your sample is this direction, you're going to go greater. If the sample is the other direction, not using minus using, you're going to go, which they have set up here, right, in that gray box, green or teal box, then it's going to be a less than. So these tests could swing either direction depending on what your setup is. All right, now the test statistic is real easy to find. It's T0, right, which is, and of course I know it's T0 from the notes right up here in step 3 of your hypothesis testing. Yep, there it is. T0 is right here, which is your D bar over your SD over the square root of n, right there. That's your test statistic. Okay, so that means that T0 is equal to, well, approximately equal to that value that we saw in there, which was negative 5.46. Okay. All right, now this is your p-value, which is approximately, well, it's approximately 0 if you look at Minitab. Let me go back to Minitab. Minitab says it's 0 right here. StatCrunch says it's less than 0.0001. I prefer StatCrunch's way of writing it because that's a little bit better, but that's okay. So it's approximately 0, or you could say it's less than 0.0001. So it's very, very, very small. All right then. So now, is it really 0 as Minitab claims? Why do I prefer that StatCrunch way of writing it? Well, that's because it's not really 0. It's just so small that the computer basically gives up. So no, not. The better way to write it is what StatCrunch does. It's a value that's less than 0.001. It's just a value that's very, very small. There you go. Now, if you only give a Minitab, then you're going to have to use Minitab and just say that it's basically 0. So you'd have to use the approximation. There. So use whichever one you have. So if you have Minitab, then use that one. If you have StatCrunch, use that one. But just keep in mind, both of these are saying that it's a very, very, very small value, which means we will most likely reject the null hypothesis, but we don't have the time to do that in this video, so I'll have to pick up there next time.